Hello everyone, this is our next video of IPSec VPN series. In the today's video, we are going to learn Internet Key Exchange IKE. So let's begin with the video. So what is IKE? The purpose of IKE protocol is negotiate, create and manage security associations. So the purpose of IKE is to manage and create security associations. This is the primary functions rules of the IKE. The second point is the SA is a generic term for set of values define IPSec features and protections applies to a connection. So we understand in the previous videos that SA is the agreements where both party will get after the negotiation. So this is the define the IPSec features and protection applied to that connection. So it is fine. So now the third point is the AC can also be manually created using values agreed upon the advance by both parties, but those ACs are not to be updated. This method was not scalable in the real life VPN, large scale VPN. So it is also fine. IK uses 5 different types of exchange to create security associations, information handles and Diffie-Hellman groups. So IK is using different types of exchange to manage the security associations. So to perform to create the IPsec VPN, IK is working. So IK is basically used for the key exchange. This is the key management protocol, I would say. So let's understand more the IPsec. So in the IPsec, it is used to secure mechanism for stabilizing IPsec protected connection. So IK is used before IK used to provide a secure mechanism. So IK is the way, or IK is the way to before forming the IPsec, it is protected. Those connection is protected by the IK only. IK exchange exchanges are main mode, aggressive mode, quick mode, information and groups. IK uses UDP 500 and in case of NAT traversal IK use 4500. So these are the port numbers. So by default IK use 500. If we are using any NAT device between that, then IK port 4500 will use it. So let's move further. So phase 1 exchange. So the purpose of IK phase 1 exchange is to IPsec endpoint successfully negotiate a secure channel through which IPsec SA can be negotiated. So the purpose of IK1 exchange to two IPsec endpoints successfully negotiate and secure channel through which IPsec SA can be negotiated. So this is the primary purpose of the phase 1 exchange. And the second, the secure channel created during phase 1 is commonly known as the IKE SA. So during the negotiation, we get the SA, and all those SA we called as the IKE SA, the secure channel created. During the negotiation, a secure channel is created. This is the secure channel phase 1. This we called as a IKE SA. This we called as a IKE SA. And the purpose of IKE SA to provide bidirectional encryption and authentication for IKE exchange. So this is used for the encryption and authentication between the both parties. The negotiation that compares phase 2, the transfer of status and error information and the creation of additional DH. So in fact, a phase 1 IK exchange must be successfully completed before any other IK exchange types can be performed. So before moving to any phase 2 or any further processing on the IPsec VPNs, so first phase 1 should be up, then other process will start. So this is the mandatory steps for the IKEs. So now we'll begin with the IKE main mode. IKE main mode negotiates the stabilize of the IKE essay through three pairs of the message. So three pairs means the six message will exchange during these transactions. So let's discuss more. In the first pair of message, each endpoints propose parameters to be used in the essay. So here both parties will send their algorithms to each other to perform or like to creating a essay. And this we are in the IKE main mode. So now what they will exchange? Encryption algorithms. This specify the algorithms to be used to encrypt data encryption algorithms. So these are the data encryption algorithms. This will be exchanged, any of them. Second, the integrity protection algorithms. This protects which keys hash algorithm should be used for the integrity protections. These are the HMAC SHA-1. So these are the media access code. So this is used to generate a hash value of the data. So I have covered already in the detail in the previous videos these HMAC and other things. So let's move it. IKE main mode. So others are the authentication method. So in IPSec we have to authenticate the connection. So here we can use the pre-shared key. Each endpoint has been given a same secret key in advance. So both sides we have to define a pre-shared key in advance. So this is the most commonly used by the organizations. Others are the digital signatures. Each endpoint has own digital signature that contains a public key that endpoints use the corresponding private key. So this is the basically the signature based authentications. Others are public key encryptions and external authentications are also there, but these are not most commonly used. The most commonly is used in nowadays the pre-shared key, where we have to define the pre-shared on the both sides. This is the most commonly used by the organizations. So other thing they will exchange is the DH group. So DH is used to generate a shared secret key for the endpoints in a secure manner, so that observer or IKE phase 1 exchange cannot determine the shared secret key. This shared secret key used to generate a value that is used to endpoint the calculation for phase 1 and phase 2 secret. So DH group is used to generate a shared secret key. Using that shared secret key, further packets will exchange in the main mode. Also generating those keys, it will used by the phase 2 also. So let's move on to my whiteboard to understand the process of this, how this will happen, this main mode exchange. Now let's say this is the site A, or I would say this is the initiator, because we are more focused on the, I will say IM. Now we have that internet connectivity, and this is connected with the other side. We will take as a responder, and let's take this site name as a B. Let me remove it. Here I will take site as a B, and I will assign the, I will take that site as a responder. This is site B, and here this is the responder. Now what will actually happen? So in the first packet, this is the packets will be exchanged during the IKE process. What information it will say? They will share your all encryption related information. What that information will contains, will send that this packet to send it. Here payload will be there, essay payload, and now other information will have the initiator key. I am writing as a short form, and now we have that SPI We'll also have that net check, and then IKE mode. IKE mode. In the essay payload, what we will have, I am just starting here, encryption algorithms. So here we are sending that essay payload, then in the essay payload, encryption algo will be there. What will be the else? The second will be the authentication algorithms. What are the auth algorithms? So I am writing as a short forms algo. Third, DH group. So which DH group will be there? And the fourth, authentication method. Auth method. And now fifth will be the lifetime. Lifetime, and by default it's a 86400 seconds. These all information will send to the responder, and the on the responder side, the responder will also send this information. Let me remove it, then we can understand more. And in the initiator cookie, so we are sending the initiator cookie also. So this was the, so we covered the payload, essay payload. So essay payload is having encryption algorithms, authentication algorithms, DH group, authentication method, lifetime. But there is another field we called as the initiator cookie. So in the initiator cookie, we have the source IP. We have the source port, source port. We have the destination port, and we have the destination IP. I will take as a DIP. We have the time. So we discussed that essay payload. We discussed the cookie, initiator cookie, and net T IKE version and IKE mode will also contain this packet. So this packet will send from initiator to responder. Now, same whatever we are sending from this packets, this is the direction I would say. Same whatever I'm sending from this packet, like initiator to responder, the responder will also reply with the same things, that essay payload, initiator cookie, SPI, net T checks, and other things. So IKE modes, net T checks, SPI. So whatever we are sending from initiator to responder side, same things will also come from the responder side. So after this negotiation, they will match the both parameters. Once these parameters will match, let me remove this thing. So till now we have covered the two packets. So first, in the first packet, the initiator have sent their values towards the responder side. In the second packet, responder is also responding with the same packet. Now in the third packet, they will generate a this initiator will generate a nonce data and DH key. Now DH will send the nonce data, we call using the, let me remove it, DH will generate a nonce data. This is the basically random data, randomization data, nonce data and DH key, which we have selected in the previously just before in this. So this third packet will send towards the receiver. Now a receiver will also respond. Let me check the colors. Yeah, receiver will also respond. What receiver will respond? Same thing, that nonce plus th key. Nonce plus th key. So both sides they have responded. Now this was the packet third and this was the packet fourth. And now we have reached the packet 5. So packet 5. So up to this packet, it was a plain text communication. Plain text. Plain text means encryption was not there till fourth packet. From this packet, encryption will start. Why the encryption will start? Because now both parties having their nonce data and th key. Both parties having, they have generated a shared secret key, which we discussed during our on the ppt. I have already showed that. So now they have generated the shared secret key, and that shared secret key they will process. And what will be the use of this shared secret key? This we can use for the, or this will use for the authentication key for phase 1. Phase 1 encryption key for phase 1, and derived key for phase 2. Derived key for phase 2. So this is the use of this key. And this, after this fifth packet, these connections are encrypted. Now nobody can see the data, and these connections are fully secured and encrypted. So the identification payload, identification fifth packet, which is encrypted. Now here the identification payload will send to the responder, and responder will also send the identification payload plus hash payload. So this is for the identifications, I would say. And first two packet, this was the key generation process. And before first, which I have removed, that was the essay proposals. So this was the video, I would say, related to that main mode negotiations. So they have generated keys on the fifth packet. Both key have exchanged, and now from fifth packet this communication will be encrypted, and that key is using for further communications in the phase 1 and phase 2. So in the phase 1 we called as authentication key, which I just mentioned here. This is the phase 1 authentication key, and this will also use as the phase 1 encryption key. Phase 1 encryption key. And in the phase 2 this will used as the derived key. So once this keys has been negotiated on both sides, the phase 1 will come up. So let's come back to my slide.